Hello dear friends, welcome to our program for science, third prep stage. Today we have some questions about Unit 4, about some parts of our curriculum in the second term. Concentrate with me very well in these parts of the curriculum and the question to try to answer them many times. Let's go to see our lesson today and concentrate with me very well. Let's go. Today we have general revision about what? About the Unit 4 and many types or many parts of our curriculum. Here we have how reactive are alkali metals with water. Here we have some amount of water, and here we have lithium, we have sodium, we have potassium, rubidium, cesium, any one of these types of metals. So we will start here. We have here the forceps and move this lithium, for example, here to make what? To make the reaction. So the kind of reaction here, it's what? It's very slow. Why? Because lithium, it's what? It's the first one in the chemical activity series of these metals. So here this one, or the lithium, so the lithium, it makes this reaction like this. But if I have next, I have sodium, for example. Sodium here, it makes the reaction more faster or more stronger like this. So here the sodium is more stronger than what? Than lithium. But if I take another one like this, so next we have what? We have potassium that move it like this to make stronger than this. Strong activity more than the two metals, the sodium and potassium. But if I have cesium like this, okay, the cesium, it is the last one. What will happen? Concentrate with me very well. If you put it here like this, boom, we have what? We have the explosion of this part, because it is the strongest metal that found in the metals in all Earth's surface. After that, we have rubidium. It's what? It's another metal that makes reaction more stronger than potassium, sodium and lithium, but it's less than the cesium. Why? Because here we have the metals react with water very fast to replace hydrogen inside water to make alkali solution like this. After that, we have here the thermal decomposition of the copper carbonate. It's very important to know the thermal decomposition. What's meant by this? It's a activity, or it's the type of chemical reaction in which the type of chemical compound converted or decomposed into simple materials like elements or simple compounds by heat energy. Let's go to see the first thing here. We have copper carbonate and we have lime water here. Lime water to detect the type of gas that produced by this activity. Let's go to see first one. As the copper carbonate is heated, what will happen? Here we have the gas formed which travels to the lime water and turns cloudy. Which one? And the copper change into green. Let's go to see. During time, we have the change of the color of the copper carbonate here from the green color to the black color. Why? Because here we have the carbon dioxide that move here. After that, we have the thermal decomposition of the copper carbonate. What is the gaseous product that appears? Here we have the carbon dioxide. And here after that, we have here, this is the equation. Thermal decomposition, the black solid product of the reaction, it's called copper oxide. Write the word equation for this one. Here we have the copper carbonate that moves here. And here we have copper oxide. And after that, we have carbon dioxide and copper oxide like this. After that, next We have the symbolic equation. Symbolic equation is very important to know the equation in the symbol or the symbols of the compound and the word equation. So here we have CuCO3, okay, that's decomposed by heat energy into carbon dioxide and copper oxide. This one is black color. Don't forget this. CuO or any type of compound that contains copper, it's very, very important to know it has color. Black color, white color, green color, blue color, any color, because this copper, it changed the color, and the copper as itself, it's red color. Next here we have which one is solid, which one is liquid, which one is gas. So the copper carbonate, it's what? It's solid one. Here we have solid. And the copper oxide, CuO, it's also solid because it makes a precipitation. But here we have carbon dioxide, it's gas. Very well. So here, this is the activity about what? About thermal decomposition. After that, which metal that react most with acid? Which one that react stronger with acid? Copper or zinc or magnesium? So the first one, click play to find out like this. The copper. If I take out the copper and put some amount of HCl, hydrochloric acid, like this, and put it here in this tube, what will happen? Nothing will happen. Why? Because here, this is what? This is no reaction that's happened. Copper is less active than hydrogen inside its what? Inside its compound or its acids. But if I make the second one, there is no budding or no bubbling that's happened in the metal because no gas is collected by boiling tube. So this means that the copper has not reacted with acids. Will zinc behave in the same way? We will see. We have the zinc. If I take 5 centimeter cube of the HCl and put it here with zinc, we have some kind of reaction. It's stronger than what? Than copper. Copper is less active or inactive one with acids. But here we have the zinc that reacts with acid and the gas that evolves collected in a boiling tube. What will happen after that? We have the gases collected here. It's lightning split like this. Okay, it's what? It's the hydrogen gas. Why? Because it makes explosion or it makes sparky pop sound. We have pop sound that comes out from hydrogen. And after that, if I take the magnesium like this, so the magnesium here, it makes reaction more stronger than zinc because it's more active than the zinc with acids and more stronger than hydrogen. So if I take 5 centimeter cube of HCl is added to the piece of magnesium, the magnesium reacts vigorously, okay, producing lots of bubbles of gas. This gas is what? That's the gas. So which type of gas? Here it's what? It's the hydrogen gas also. After that, how did the salt obtain from copper oxide powder? So here we have the sulfuric acid, we have copper oxide, here we have, this is double substitution reaction or double replacement reaction between sulfuric acid and copper oxide. If I take some amount of copper oxide and move it inside or dissolve it inside H2SO4, what will happen? Change into what? Change into blue color. Why? Because here the copper oxide powder is added to sulfuric acid, it dissolves it, causing the blue color or dark blue color. Why? Here we have stage 2. Eventually, the solution cannot dissolve any more of the powder because the reaction is complete. So we have here, this is the reaction complete, so the excess of copper oxide just floats on the surface of this solution. After that, here we have the excess of copper. What will happen here? This is what? This is the filtration of this part. So it makes what? It makes some kind of compound that produce by filter paper. The filter or filtrate, it is collected and evaporating dish. Okay. After that, the last part or the stage 4, filtrate contains the copper sulfate, salt formed by the reaction. So if I heat this amount of solution. So we have some parts of the copper sulfate that produced here by a blue color after heating and evaporate the water. So the salt is separated from the solution by evaporation of water. Let's go to see another one. What's happened for lime water when calcium carbonate is added to the acid? Concentrate with me very well. We have the calcium carbonate and lime water. Here we have the calcium carbonate here, okay, and water here. What will happen if you add this calcium carbonate to the acid? Here we have the acid plus calcium carbonate, and we have a gas that move inside the lime water. Lime water turns milky. Why? Because the lime water, it change into milky color by the effect of carbon dioxide gas that flows downward to make dissolving in this lime water and react with this compound. But what happened of the lime water when the calcium carbonate is added to the acid? Any type of carbonate, it is a base. Remember this, it's a base or a rule. That's any type of carbonate, calcium carbonate, sodium carbonate, magnesium carbonate, react with any type of acid, sulfuric acid, hydrochloric acid, nitric acid, it makes carbon dioxide gas. Why? Because it's the reaction, substitution between them, and the last part of this substitution produce carbon dioxide that change lime water into milky color. After that, we have another type of question, define the following. What's meant by define the following? I need the definition of the first one. We have electric current intensity, the quantity of a chain of charges that transfer between 2 points of the conductor in 1 second. Again, electric current intensity, it is the quantity of charges that transfer between 2 points of the conductor in 1 second. After that, we have another definition. We have the alkali. Alkali, it means what? It means the substance which produced negative ion of hydroxide ion that change litmus paper into blue color. Again, we have alkali solution or alkaline solution. It makes what? It means the substance or solution that produce negative ion of the hydroxide that change litmus paper into blue color. Another one, we have volt. What's meant by volt? Volt, it means it's the potential difference that produced by 1 joule of work done. Again, it's the potential difference. I make the definition of the units from its rules. Volt, it means 1 joule divide 1 coulomb. So it's the work done to transfer. It must be 1 joule of work done to transfer 1 coulomb of what? Of charges between 2 points of any conductor or any wire. After that, you have the radioactivity. What's meant by radioactivity? Radioactivity, it means it is the emission of the radiation by an atom of radioactive element by itself. It's very important to know this again. Radioactivity, it's the emission of the radiation by an atom of the radioactive element by itself. It must be by itself. After that, we have acid. What's meant by acid? It's the opposite of alkali solution. Excellent. So it is the substance that produces the positive ion of hydrogen in the solution that change litmus paper into red color. Excellent. So again, we have the acid and we have alkali. We must have the comparison between them, acid and alkali. So it is the substance that produces the positive ion of hydrogen in the solution that change litmus paper into red color. It is not blue color. Remember this. Another definition, we have chemical reaction. What's meant by chemical reaction? It's the breaking bond between reactants and forming new bonds in the product. Again, it's very important to know this one. It's very famous in your exams. Chemical reaction, it means the breaking bonds between reactants and forming new bonds in the products. After that, we have ohm. Ohm, it means what? It means it is a measuring unit of what? Of resistance, right? But it is not the definition. What's meant by this definition? It's the resistance of a conductor when the potential difference is 1 volt and the electric current intensity is 1 ampere. Again, it's very important to know this. Ohm, it's the resistance. It is the measuring unit, also it is the measuring unit of resistance, but it is not the definition. We have the definition, it's the resistance of the conductor when the potential difference is 1 volt and the electric current intensity is 1 ampere. So we have another type of question. We have complete the following. From the catalyst that we use it in catalytic converter, we have what? We have the first one, it's excellent, we have MnO2, manganese dioxide, and we have the second one, we have V2O5, that's called vanadium pentoxide. Again, we have from catalyst that's used in catalytic converter, it means what? We have two examples. MnO2, you write the symbol is right. If you write the name is right. So we have V2O5, and this another one of this catalyst that used in catalytic converter. And we have many types of catalysts like enzymes, like what? Like amylase enzyme, like for example the enzymes that found in the potatoes or sweet potatoes to make the reaction or decomposition of some kind of sugar. After that, we have another one here. We have a space is used in measuring current intensity, but what? But space is used in measuring the potential difference. What will happen here? We have here two different information used in measuring current intensity. Which one? Here we have what? Here we have this ammeter, right? So the ammeter is used in measuring the current intensity, but space is used in measuring what? Measuring potential difference. We have voltmeter. Excellent. It's very easy to know this. After that, we have the resistance is measured by what? By unit, by space unit. But current intensity or I, that's what? That's measured by space unit. Which unit that measure every one or each one of them? First one we have what? We have ohm. And the second one it's what? It's ampere. Again, it's very important to know the units or the device. Here I need units. So the resistance, it's measured by ohm unit, but the current intensity is measured by ampere unit. So here, this is the types of units. But if I have the device, here the resistance, it makes what? It makes the ohm. Ohm here, it means it is not the device. We have ohm meter. But in the ampere, it's the unit. But I need the device that called ampere. Or that called what? That called ammeter. It is not ampere, it's called ammeter if I have the device. Now we have another type of questions that called problems. It's very important to know the problem. Any part of this problem, I must write the rule. Again, you must write the rule, and after that substitute the rule or the symbols by the numbers and calculate anything about this. So we have the problems, it's very important part. The first one, you have three similar cells. The EMF of each is 1.5 volts. Explain by using diagram. How can you connect them to obtain? Again, I need a connection, a type of connection that if I use the three similar cells, all the number of the cells that found in this problem, we must use it. Why? Because I need to use all of them to produce EMF by a type or by a value, a constant value. Let's go to see. We have the first one, I need to connect them to make what? 4.5 volts. And the second one, I need to connect them to make or to produce 1.5 volts. And the last one, I need to connect them to make 3 volts. So here we have to obtain 4.5 volts. It's very important to know this is series connection. We have the first battery here, second battery, and the third cell. So here we have, this is what? This is the three cells that form a battery. That makes what? That make the cell are connected in series connection. So this one, it's called series connection to make 4 and 5 volts. Let's go to see the second one. We have to obtain 1.5 volts. The cells are connected in parallel connection. Parallel connection, it means three cells. that found here, we must make the connected in the parallel. It means all negative poles are connected to each other in one point, and all the positive poles that connected to each other in one point, and we have 2 points that's connected to the voltmeter to measure the number of volts that produced by this, and it will be 1.5 volt. After that, the last part of this one, we have to obtain 3 volts. It's very easy to know. We have 3 volts here. We have the first one here. We have 1.5 and 1.5 in parallel connection to make one battery produce 1.5 volt. But here we have another cell that contains 1.5 volt that connected seriously with this parallel connection to make what? To make this volt that contains 3 volts here. Another problem, calculate the resistance of the conductor if the potential difference of it is 2 volts and the electric current intensity is 10 amperes. So here we have 2 volts, it's the V, and the electric current is 10 amperes. So I calculate the resistance. Is very easy to know this. So the answer is, we have R equal V divide I. R equal 2 divide 10. We have 2 amperes. Or 2 volts divide 10 is very easy to know. 2 divide 10 equal 0.2 ohm. Again, we have R equal V divide I. You must write the rule. And we have R equal 2 divide 10. So the answer is 0.2 ohm. This is what? This is the rules of how can you answer the problems here. Another one of this problem, calculate the electric current intensity that pass in the conductor when the quantity of the electric charges is 10 coulombs. Pass in 100 seconds. It's very easy. We have what? We have a rule here. The answer will be I equal Q divide T. I equal 10 coulombs. Divide what? Divide 100 seconds. So 10 coulombs divide 100 seconds equal 0.1 ampere. Don't forget the device. Sorry, don't forget the unit that measure the result of our problem. Why? Because it has half mark here. So you must write the rule. You have the first mark. You substitute the rules or the symbols by what? By the numbers. So the second mark here. And the last part, we have 2 marks here. 2 marks about what? Half mark about the result and half mark about the units. It must write it right like this. Here we have another type of question that study the following figure, then answer the questions here. First thing, we have the figure here. We have a graph, and this graph, it contains 3 curves here. The first curve in the blue color, second curve, and we have the yellow color, and the first curve or the last curve, it's what? It's dotted one in green color. So what is the questions here? In the following equation, we have 2x give us 2y plus 2z. It's a chemical reaction, and we have the concentration of the reaction in or on what? On the y-axis, and we have time per minute in the x-axis. The question in the opposite graph represent the change of concentration of the reactants and the product during time. So I need what? I need a question. Question is in the following equation, 2x give 2y plus z. Write the name of each number indicates. Number 1, number 2, number 3 indicates which part of this equation. So the answer is the change of reactants and the products of this reaction during time in a table. So here we have the number of reactants, it's 2x. The number 2 represents what? Represents z. And the number 3 represents 2y. And after that we have the table here. You must write this in table. Beginning of the reaction, we have the concentration of 2x or the reactants. It's 100% without any make or any doing of reaction. So the concentration of 2y and z, this is 0%. Why? Because here there is no production that happened because we have no chemical reaction that takes place. And during the reaction, decreasing gradually of the concentration of the reactants, 2x decreasing, 2y and z increasing, the opposite of each other. And the last part here we have the end of reaction. Concentration of 2x will be 0%. And the concentration of the products here 2y and z, they are 100%. Why? Because the chemical reaction that's complete and produce the last amount or the last value of what? Of the product 2y and z. It's very important to know this and concentrate in each part of this reaction and concentrate in each type of these questions here. Dear friends, I hope to enjoy your time with us. Till we meet again in another part of the curriculum in revision. Till we meet again, thank you and goodbye everybody.